Okay, so the first problem we're going to do is this one right here, number 21, where it asks us to find prime factorization. It says, Mr. Gonzalez shows students part of the prime factorization of 90. One factor is missing. So we have 2 times 3 to the power of 2 times, and there's a blank here. Which number completes this prime factorization? And so this goes back to what we had learned earlier. And that's how to do this. And we took the number and we actually used those little bitty centimeter cubes also for some of you. But in some cases the numbers are so big that using the little centimeter cubes might be a little bit too much. Like if they say like the prime factorization of 240, it might be quite laborious or laborious to count out 240. But some of you do not forget, use your hundreds chart to make sure that you count correctly. Okay, so anyhow, when we're looking for prime factorization, we're actually just trying to find all the prime numbers that we can multiply together to find this particular number that we're looking for. In this case, it's 90. Sorry, I'm spelling factorization like fractorization, which is wrong. So let me spell it the correct way. Once again, students, you have to get used to my cursive. It's the best way to write. It's nice and simple, and it's just great. Okay, so prime factorization. Some of the numbers I told you to remember, because these are factors, are prime numbers. 2, 3, 5, 7, not 8, not 9, not 10, 11, 13, and these are like some very common ones. So let's get over here and let's start working these out a little bit. Okay, so the first thing I'm going to do is I'm going to look on my multiplication chart and I'm going to see, can I find the number 90 inside the multiplication chart? When I do, I'm going to go look up to the top and to the left to see what are those 2 numbers. When I look on the top and to the left, I'm going to see a 10 and I'm going to see a 9. Now if I look over here, 9 and 10 are in between the numbers of 2 and 13, but neither one of them are prime. So I'm going to actually have to go in here and work this out. So I'm going to look on my multiplication chart, or if I remember my facts, I'm going to look for a 10 and look and see what 2 numbers do I multiply to make a 10. I'm going to go up this way, and I might see a 2, and then this way, I might see a 5, or I might go up this way and see a 5, and then this way I see a 2. Either way, that's fine. I got 5, and I have a 2. These 2 numbers, they are prime numbers, as you can see right here, the 2 and the 5. So I am going to go ahead and circle my prime numbers. That lets me know I do not have to work with them again. But I do have to come over here and I have to work with the 9. So let's see. If I get on my multiplication chart and I look for 9, I'll see that if I go from 9 and go up, I'll see a 3. And then if I go to the left, I'll see another 3. So there goes one of my 3s. There goes my other 3. These are also prime numbers. So I'm going to circle them. So what happens is, this is telling me that if I like to put the numbers in order of from least to great. So that means if I do 2 times 3 times 3 times 5, these would equal 90. And I can get on my calculator and I can double check it to make sure that it would, yes indeed, equal 90. But here, these two numbers here, I can actually write them like an exponent. Because if you look over here, that is 3 to the power of 2. That's exactly what this is. So this right here, if I was to rewrite it, it would be 3 to the power of 2. This is not 3 times 2 makes 6. This number, which is a power, tells me how many times I'm going to multiply 3 to get my answer. So in this case, I'm going to multiply 3 2 times. As you can see here, I'm multiplying 1 3, and another 3 together. So if I bring all of this down, I have 2 times 3 to the second power times 5. So my missing number, this number over here, is a 5. I really hope that helped you with that number.